take the trash to the bottom of the driveway.
Jeremy.
So they can, and then they'll have to put the trash in and they'll go back to the garage, stuff like that.
Coffee
As
machine
a whole.
working.
Or it's like a,
It's a regular robot.
oh, okay.
So there's no.
Okay.
So he's been working on it for.
Hey.
There's all kinds of stuff. Yeah.
It's semi-autonomous. It's programmed to go to the edge of the driveway and wait for somebody to hit a button and tell it to go back home.
Okay. So does it releases so the trash guy can pick it up?
No, the cans are still inside of it. When we started that project, we had talked to the trash guy, and he didn't have a problem taking them out. He wasn't so sure that he was going to put them back in.
Yeah.
But we approached it as a thing for possibly the elderly to use.
Yeah.
So he was like, yeah, if you talk to the right people, they may be more receptive to doing something like that because, the elderly
Right.
aren't able to take their trash down. So it's still Jim's been working on it for probably 2 years
If
now.
someone comes up with another idea how to get the back end, but then they re-engineer it. We'll go this way.
Yeah, it's
So it
still,
kind of morphs.
it may or may not ever actually do what we want it to do,
But they'll cover a lot
It's
of
fun.
bases while they're doing it.
Yeah.
it's fun.
Hello.
Hello.
The meetup?
The right place.
I'm on the right place. It's Kevin.
Hi, Kevin. Don't we sound like a support group now?
No, it's all right. It was the first time here, so let's just say hello.
So what do we got
What's your
here?
name again?
Jeff.
Jeff, and it's his first time.
All right.
He
And-
comes from Dayton.
All right.
And if you guys get on Meetup, and say something to the group, we can get you like on the mailing list, which I don't think Jim sent the mailing list out this morning.
I didn't
did he?
get it. I don't think I got an email.
I don't think, but
I have one. The garage.
yeah, maybe
open.
we did. I don't
Yes,
remember.
yes, I saw it.
Jim, who's really in charge of this mess, he's pretty good about sending emails about what we're going to be doing for the
together.
meetings.
Yeah, I got a notice
So-
about, it was an open topic.
Yeah.
I thought you meant another email.
No, but he usually tries to get your guys' email address and whatever when you're here. I don't really do that.
Okay, now I'm supposed to. Okay. Which one is it? The connection?
HTB,
STB 63.
that's it.
Okay. Connect.
2 weeks ago, we ran out of chairs.
Yeah.
It was pretty full. Usually there's 2 or 3 empty chairs. So
Look, I'm a kid. I'm building stuff.
Sure this works.
It's supposed to work.
Connecting.
What's this guy gonna be doing?
Okay, connected. Well, that's the slim down version.
Oh, okay.
Using that mode chip. But I'm gonna go over the old one and then see how we got it. Okay, so let me bring up Chrome.
You're right. I got an email.
I can't find it.
Sometimes I have to read those emails just to find out what it is I'm doing. Oh yeah, I did say I was doing that.
I'm casting to
It's meeting ring or meeting
TV.
something like that.
So you live around here?
I do. I live over in Springdale. Cast.
Yeah, it's not too far.
And I don't want to cast tabs.
You want At the desktop, yeah.
That's all.
There's guy Steve, he was gonna be
We
here,
had
but
to,
he emailed me and said I'm up at Cleveland and I won't be able to make the meeting because I'm tied up here in Cleveland for the, but he works around here, but he lives in Evanston.
Okay.
So he's out here working and he doesn't have to drive from Evanston to get here. So,
I'm probably going to end
But
up
I
getting
met
that,
him.
even though I think that's pricey.
he's the president
And
of the
wait for
Sealer
him.
Group, the Linux
For it to
Group.
come down.
yeah.
Yeah,
And then I told him about this.
it just seems pricey right now.
He does IT stuff and he tinkers with stuff too, so I knew that this would be a good,
I'll be buying the second release,
he'd be liking that.
the 10th
But
version.
it makes me wonder, because they released the AI shortly after Google Home, so it makes me wonder if they've got bigger plans to do something.
Conglomeration of brain.
They are trying a lot of stuff, I think.
Yeah.
I'm guessing,
Yeah.
All right.
I'm wondering if any sound's gonna come out.
There's the man.
Okay, speakers, do I need my speakers or?
It should come off the TV.
So let's see if I say anything. Video describes my, Internet of Things garage open application. And in particular. Let me just stop it for a second. Okay. This thing it's 35 minutes long. I couldn't get it any shorter. I was gonna put it on YouTube, but when I shrink it down a little bit, I'll put it up on YouTube. But it basically talks about the journey I've been on. I have a garage door opener controller that I can control from the internet. And it's a little bit bigger box, and I also have it connected through Ethernet. And this little box here, I got everything on. This is something that Leroy discovered, and it's got a Wi-Fi chip. It's got 4 relays, and you can connect the wiring, into the garage door opener box, and you can connect into the network through Wi-Fi.
So did you build that board or was that a board you
This
bought?
is you bought.
No.
Okay.
I built this on using Tinkercad, and I got a 3D printer, and I printed it. It's not perfect. Probably got to print it a couple more times. It takes 2.5 hours to make these things, so you get kind of reluctant. So I'm gonna describe this, and so let me get it started again. Upgrade the hardware, and as a result, have to do some software upgrade. But what this is mostly about is syncing the hardware, whereas the original was direct
Turn it up
Wi-Fi
here.
connection. I think he's got control. The new unit's going to be wireless, but it still demonstrates all the thing concepts. Let's get started. This is a porting project. That is, there's a garage door opener that was created with a Arduino microprocessor that will control the 3 garage door bays as well as a light switch, ability to sense the temperature and display that on a phone, on a tablet, or a computer desktop. I'm going to talk about the operation of the garage door opener system and the current software and hardware. And I made changes to a new hardware architecture to take advantage of some extra speed and extra memory, shrunk the size. And I'll talk a little bit about the software, some issues, and I'll show you what the old application looks like and what the new application looks like, and I'll talk a little bit about next steps. I just put the next step in here, but next step is an Android app.
Controlled over the internet, a block diagram to give you a picture of just how it works. A web browser, whether it's on a PC, a tablet, or a phone, is your user interface, and you'll have buttons. Communicate through the cloud to an Arduino microprocessor, which happens to be mounted in the garage, that can supply, basically close a loop to a light control or to a relay control. These and light controls will turn garage door openers on and off in the garage. That is, they will cause the garage door to go up and down. There's an additional feature where there's a temperature sensor, and the web server can read that sensor and transmit the results back to the browser, and it will be displayed in a demo a little bit later. This is the current prototype hardware.
That's what's mounted now.
And it's mounted in a metal box in the garage. And what you see here, even though it's not real clear, is there is a shield or an internet connection shield that's mounted on top of an Arduino microprocessor. Together, they provide processing power for the logic to open garage doors, close garage doors, etc. And this is actually a wired unit. I have an Ethernet
Runs from the garage to the
cable
basement.
that runs from the garage router and out to the internet. What you see here, these are 8 relays. In this circuit, I use 4 of them, but there's an extra 4 if I wanted to control other devices. My light switch is a wireless control, and so the Arduino here can trigger this Wi-Fi controller, and then there's a remote that I'll have a light plugged into, and that light will go on and off. Can be used, for example, for Christmas tree light circuit. And this just is the connector that brings wiring from the garage into control box. So this is a good size unit that's about 4 or 5 inches across. It's and it's about 6 or 7 inches down. The new one's much smaller than that. Okay, we're looking at the controls. We have a control for garage door 1. There's a button, one for garage door 2, garage door 3, and a light switch. Additionally, we display the temperature, and we show the status of all of the doors. So what I'm going to do here is open one of the doors. Okay, looks like I have to log in again. And I'll log in. And try door number 3 again. Notice on the right-hand side, door number 3 is going up. And the status tells us that door number 3 is up. I'll let it up, go all the way up, and then I'll close it. These are push-on, push-off controls. So now I'm going to close the door. And it goes down. And let's look at status. It says the door is going down. It's all the way closed. And that's how it works with the other controls also. The new box is shown here. This plastic case was created on a website called Tinkercad, printed it on a 3D printer. And this is where the new unit will reside. The new unit is a link node R4, that's a designation. It's made by a company called Link Sprite. The lines here shows the connection. These are where the wiring connections go to the garage and the lights, and you can see there are 4. This is the processing unit with the built-in Wi-Fi. The other unit was wired. This one's completely wired, wireless. It has 1 5-volt power supply, which connects right here, and the power and the garage cables are the only connections. This is the code for the Link Node R4 version of the opener. At the top, you see some included libraries. There are 4 of them. And these libraries contain functions that are required, or standard functions that are required by the application to do things like automatically connect to the Wi-Fi and various other functions. And we start off by using one class, which is a Wi-Fi client, and we give it the local name. The object will be called client. We have the ESPA266 web server class, and we're gonna instantiate that with the name of server, instantiate object, and we're gonna pass to it port 80. And next I'm gonna go to the setup, which is where you start with all Arduino programs. And you do your basic initialization and all the things that you need to do to get started with the program. I'm sure I'll find here someplace to set up. Oh, there it is. And it starts up the serial object with serial.begin and sets the baud rate. And this is used for debugging. And the Wi-Fi.begin will start up the Wi-Fi object, which will connect to the router and in the long run get you connected to the internet.
Wi-Fi manager.
And
It is.
we're also going to set each of the relays to 0, or basically turn them off. And then we're going to wait for the Wi-Fi to be connected. And during that time of waiting, in the console for debugging, you'll see a dot being printed. And then after it's connected, we get a little message that says it's connected, specify the SSID, which is the ID of the router, and it will give you your address, your local IP address. This is a label, and the Wi-Fi.local IP will actually give you the IP. And the IP that you get will be dynamic. So the circuit
One I have now is static.
will
It's never
request and
changed.
get an IP. And then we'll do some more initialization.
So you have to lock this out in the router. Like,
This is a library method to initialize the root function and the handle login. These are 2 very important processes or functions, actually functions. So now I'm going to take you to the bottom and show you the loop.
that stuff is all handled in the
this
library,
code
so it's almost like a mystery.
This
You
is
just
also
have to
a,
assume that it works,
library,
and it does.
And what it does is
It's magic.
it will call
It's magic.
the client root and login. Let's go up and look at them.
Even if you look at the code, it's hard to figure out exactly what's
Login
happening.
handles and the root handles. Here's the handle login. And first thing that it does, it checks to see if a cookie is found. Basically, if there is a cookie, then that means you have permissions to log in. The login also checks the disconnect. There's a disconnect button. And if that button is clicked, it will allow for a disconnect. If both of those checks fail, another check will be done to see if the username and the password have been, and if that doesn't happen, then you get this, you get the login code here. You get a text box that has login and password, and you type in the login and password. And if the password and login is in there during the next time through, you'll make this check here, and you will have successfully logged in. The next, and probably the most important thing that's going to be done is you're going to handle the root. And this checks if authentication is good. And if it's not, the message will be sent, basically 301. And let's say things are authenticated. Then, of course, you're going to display your HTML that is the user interface. And what you're doing is you have a variable and you're just concatenating all of the HTML, basically the entire web page, into one variable. And then we're going to send that to a browser. And that's what you see on the screen. And after that's done, you will do some checks here to see if someone clicked the button. And if the argument button 1 is on, which you will see in your browser address bar, then of course you do a digital write and you'll turn you do a digital write to pin 13.
Where you do that stuff is you copy the code from somebody else who has done it.
Don't reinvent the wheel.
You say, hey, Leroy, how did you get this thing to work?
We stand on the shoulders of giants.
Yeah.
To that library, it all comes out of the library.
The library is there, but actually there are pieces of code that comes from all over the place.
And if that's all and processed, you just print a line that says the client is disconnected.
Just for debugging.
Really not totally disconnected. What's going to happen is you're going to go back down and you're going to get into this loop again, and you're going to do those checks all over again to look for input. And if the login is not valid, then you're going to display a login screen for the user. If the cookie is still good and you're logged in, then you're going to display the user interface for the buttons and look for button quickies. And this just continues forever. So that is the code, and much of what happens here goes on in the library, which is kind of hidden. But if you need to, you can go to this ESP8266 webserver.h and .cpp, and you can see what's going on there. This is the layout for the new user interface. And as you can see here, there's a button to open a door and a button to closure. And additionally, there is a disconnect when you want to leave or log off of the system.
After I did this, I figured out how to get the temperature back. This thing
So
doesn't.
instead of pressing one button, you get an
Yeah, I have to. I still may go back to one button.
It's in a red case. This is
Quick question.
Yeah.
3D.
Are you inferring the door state from the relay state, or do you have sensors on the door?
No, I don't have
And
sensors. I
you
just
see
keep track.
that it has a single power connection.
I have a plan for adding
Here's,
sensors. Extra stuff.
had 2 power supplies.
The garage door probably
And,
has sensors.
Yeah, it does, but you need to get sensors into this
Its operation.
processor. It has to know what the states are.
As I click the buttons on the user interface, you'll see the lights that correspond to each relay come on. So now let me
I'm
open
just
it
doing that on
up.
the screen. Video in this stuff is not a picnic
And you
either.
see, it's a light is on,
Takes 4 hours to do a half-hour video.
that light goes off. Open door 2, corresponding, light goes on. Close door 2, goes off. Door 3, door 3 off. Lights on. Lights off. And of course, in the garage setting, there will be wiring that goes from this unit to the relays on the garage door openers. And
What you do is you inject it, you know, where you have the push button switch,
box has
you just put it
been
in parallel.
set up so that the wiring
And then wiring from this thing in parallel.
to these connectors. You know, go look on the
It
other
acts
side,
like just another switch.
similar. When I got the box turned wrong. So the wiring goes in through there. This box is also on Tinkercad.
Take your own design.
That's some TV stuff too. And I don't know what, I asked, well, I couldn't get a box that size. So I
Software,
decided-
both of these applications, the first iteration and the second iteration of the garage door opener, were created on an Arduino IDE, that is Integrated Development Environment. And they use the C++ language. And you start these kinds of projects with example code, and I'll show that a little bit later, but this
I already showed it, that's why I know I got it in there twice.
the ID interface.
Is that what you're gonna pare down before you put it on?
What you're actually end up doing is you start out with a basic framework, and then you add your code to match up to your custom circumstance. The IDE also is good for debugging. I'm not gonna show you the code for the original. I will just do a quick run through of the
And I already did the run through, so I
link node.
probably move ahead.
And it gives you an idea of what the code's like, and you know what your outcome should look like. It would take much too long to go through this code in detail. And there are, again, plenty of examples on the web of how to use the code.
There's the code
I
again.
want to show you one last thing.
Okay,
about
we haven't
the
got to it
code.
again though.
I mentioned before that there were
It's a little bit
examples
ahead
that
of
you
this.
can use. And let me give you an example that can be used for a web server of the type that I'm demonstrating here. If I go to examples, there are many examples for the Arduino. Now this happens to be an ESP8266, so we have to go to that category to find good examples. And the one that I would recommend looking at is the advanced web server. And it has the same
So
handle
you get a
root
basic framework,
structure.
and then you start playing with it.
It doesn't have a handle login function, so that would be something that would have to be added. But it is a complete web server, and it can be used to show you how a web server is set up. The content of this one is completely different except for the libraries and the standard variables, but the handle root is completely different. This program that you're looking at will run exactly as is. So it's a good idea to run something like this to give you a little confidence that this does work and to give you a framework to start out with. As I said before, it's not going to solve all your problems, but the good thing about Arduino is that it gives you a good starting point for writing code.
Okay, this is where I added the extra stuff. I added it in again because I thought it wasn't there.
This is the
And I didn't want to listen to it for another 25
code
minutes.
for the link node
So I
R4
need to
version of the opener.
pause it for a second here. I need to move ahead.
You see some included libraries.
Let me find my.
There are 4 of them. And these libraries contain required or standard functions that are required by the application. Things like automatically connect to the Wi-Fi and various other functions. Similarly,
I'm messing up.
I got the box turned wrong.
You went backwards in time.
Okay, there it is. I see it. I couldn't see the
So the
line
wiring goes in through there.
because I'm actually down to the summary now.
We have the ESP8266 web server
Did it
class,
take you back?
and we gotta instantiate
I'm repeating
the
it.
console for
Okay.
looking. You'll see the dot method,
Okay.
and it's gonna initialize the root function and the library method.
Boy.
And what it does is it will call the here's the handle login, and the first thing that it does,
This is pretty long.
the client is disconnected this R4 device. But I found that I had
Still got the voice.
I got a better outcome, and it worked better with some of the older
Okay.
libraries that were there for the initial ESP8266 processor line.
I used some of the codes that we used when we
documentation
first started doing the
desired for the
ESP8266.
link node device.
Basically, that
Once
Wi-Fi
you
management
figure out
stuff
how it
is a
works,
problem.
It's like most devices, you can be pretty effective and get things done fast, but there's a learning curve. For example, one of the things I learned is that you have to power cycle the board every time you
Nobody
reload it,
tells you that.
which is not the case with standard Arduino. There's no power switch on the board, so you physically have to disconnect power. The physical platform, big advantage, the physical platform is much smaller, and you can use 1.5 volt power supply. On the previous version, I had a power supply for the relays and a power supply for the Arduino complex. Overall, it also consumes less power. Another thing that the link node could use to make it even better is a few more input-output pins that you can connect to other sensor devices. But overall, once you get the hang of it and learn how it works, it's fairly easy to use, and the smaller footprint definitely makes it better. I hope you get something out of this, and I hope it helps you along the way to doing your own Internet of Things projects.
One of the things I found out is, and I haven't really checked it out, but the pins are on the chip. I mean, there are some more I/O pins.
Mhm.
You just need to run them out to the edge of the board somehow. But it's not going to be that many. And for instance, I can't do the temperature on this. Well, I can't up to now, it's because I don't have a pin so that I can read the temperature. And it's probably not an analog either. So I mean, I have to use a digital read. But in any case, you get to the point where this is small, this is very compact, but just in other cases, you run out of pins. And you need pins to do extra input, extra output kind of things. But it's not that great using this FDII thing either, but that works.
It's a-
After you get the hang of it, you know, you can load code and it works, but I messed around with this for a week. Shit. It was awful.
Actually, he messed around with it for probably 2 weeks and then threw it back to me and said, "What did you do to make this thing work?"
But you know, I say this, everybody says it. After you put your time in, you're okay. I don't have any complaints, but it's hard to get around it.
That particular processor, for whatever reason, it must be an older ESP8266, because it only wanted to program correctly at like 5700 baud.
I can make it work. I make it work at the higher baud.
Wow. I can
The
make it
difference
work.
is, were you using those Wi-Fi maker libraries?
No.
That was my problem. Once I got away from that and I started using stuff that we used to use when we first started experimenting with this, it worked.
I don't know what I was using, but it only wanted to program correctly for me at 5700 baud. So
I made kind of another breakthrough, and I started having more success with Android Studio. So I have faith that it works. So that tablet UI kind of thing, I think I might be able to put it into Android Studios and use a Android phone for control.
you know what might have been my FTDI chip it might not have liked the chip I was using. That's why it needed a different speed.
Yeah, it could be.
Could have been.
Anyway, that saga's over. And
It's a neat little
another
board.
thing I figured out I was going to do too, because I don't have that now. With something like this, I could even put like a backup battery, and so if power was lost, you know, I put one of those gel things in there that lasts for 2 or 3 days if it lost power.
And what would that give you? Because if power was lost, you're not gonna open the door anyway.
Yeah, but you want to communicate with the thing, and the other thing too is I have a camera, so.
Okay.
And in the beginning, I just wanted to work. You think of more things. The other thing that this one does is you can do a better job on security because you have more code space. I first did this with an Arduino, and just running the application, you know, I was out of everything. Then I put a Mega in there, which is a bigger board, and that was better. This one's got twice the memory, twice the speed, and so you can add more security kind of stuff in it, which is a good thing. I thought a lot about the security thing too. You know, since in my case, you can get great security because you're only supposed to get input from one source. So you could even check, you know, on the IP range of where this thing should come from. And that's going to limit who can get into it. You can also, like in my case, I didn't think about this before, but I can come into a gateway, I mean, not a gateway as some little device like this, but a real gateway, you know, a router and a real server. So, I mean, I could limit it that way. When people do these things, the Amazon lock.
New door lock thing I see.
This is actually similar to that. And people are really worried about, you know, people hacking into it. You've had two.
My mom used to own a Jeep, and she would lock the doors, and I'm like, why would you lock the doors to a soft top Jeep? All somebody has to do is just.
They're in there.
She said, oh, you know, I never thought about that. You're right. All they have to do is just rip the top.
Well, they'd have
If
to
you
break
leave your
some.
door open, they at least won't rip the top.
Yeah, that's what I said.
But, yeah, actually, it's really true. My wife and I talk about it all the time. These houses out here got all kinds of glass, you know, so you just have to count on goodwill or something. Because if somebody really want to get you.
Yeah, the good old fashioned brick version
Yeah.
1.0.
Yeah. No glasses, unless it's super flexy, whatever.
Okay, your turn.
Oh. My turn.
Well, before you do it, tell us what you're doing.
I'm hitting a button. Oh, it's still not quite right.
It's trying, but
It is trying.
It might be going a bit too fast.
Going fast in a very small space.
So what this? Oh, look! It actually made the turn.
Yeah, it is.
Yeah, but it was actually when ran into that one going too fast.
So what this actually is, this is called a protractor. It was a Kickstarter project, and it's measuring angles. And it can track, I think it's set up to 3 objects. And you can use it for obstacle or avoidance or hitting an obstacle or whatever. Doesn't really like my box.
I think they have something like that built into the new version of that robot, because that's one of the demos they did.
Is it a contract with the box or is it sitting in the box?
You can never go back.
I think it's speed.
It may be speed. I'm not real sure. It may be, see it's slowing down when it.
But never goes back, right?
What do you mean it never goes backwards?
It sees it.
When it hits up.
It's just clipping them.
Right, it doesn't go backwards. I think it's because everything's too close. Because the thing says 12 inches.
It's still turning away from the. Looks
Yeah,
like it's just going too fast to make a turn.
It definitely appears to actually be working
Triangle.
in my very small, less than 12 inches of a box.
I don't think you can see that.
Did you try it on the floor?
I tried it on the
I got
floor.
to the wood.
Okay, so the carpet at the house is actually very, very dark. And it has a big problem with the dark carpet. And it sees stuff that's not there.
That's because it's infrared and it's affected by light conditions.
Now you turned it the other way.
I don't think it sees the box very well.
No, I don't think it sees the box very well. I had it doing figure eights the other day, so I know it actually.
Have you seen the demo with the new version of that?
No.
One of the demos, it does this kind of stuff, because obstacle avoidance.
Look, it's actually kind of working. It kind of found its groove. I forget what I paid for this. I think it was like $35 or something. It's supposed to work with he designed it to work with this robot, which is why I borrowed the robot from Frank. But it's supposed to work with anything. I brought the other computer if we want to program it or whatever to do other things, but I'm still trying to wrap my head around what it actually is telling me it's doing. So I'm sitting there going,
Well, you know, last time you had this monitor that you could see what was going on. You got a display.
mm-hmm.
On the real time video.
Yeah. That's in a groove.
Yep.
A nice car right there.
Yeah.
Oh! No! It still hit something, but it got around it.
Yeah, it's thinking. You can tell it's thinking.
No!
Sharp turn. Maybe you're right about the
Just a working groove into that cardboard after a while.
The website says 12 inches. And obviously, this is not 12 inches.
It's actually doing quite well.
It's moving pretty fast.
Did you buy it with the robot or did you integrate it into the driver?
The robot is Frank's.
Okay, okay.
It's integrated.
So,
You can use this thing with line tracers, and also I got a board that it does collision for you. The real trick to this thing is I have these high school kids. First of all, you get them to program it, and then they all put their robots in there and knock each other out of the ring. Like a sumo. Yeah.
what I bought is just on the top. The board is just an Uno. So what I bought was just on the top, and it seemed like it was reasonably priced. Otherwise, I probably wouldn't have bought it because I'm cheap. 27 bucks, 30 bucks, something like that. You know, almost everybody else here knows I do a lot stuff. So eventually I wanted to see it actually work on a robot it was designed for, so I could try to figure out in my own head moving it over to one of my robots. Now, I'm not exactly sure what it actually is telling me. I mean
So how is that connected in? You have some input pins that you're reading?
it's I2C.
Okay, I can see.
It's hooked up I2C right now. It can also do serial, just plain ordinary 9600 baud serial.
What
Yeah,
gives
you were
you
saying that
distances?
box, it takes 2.5
Angles?
hours for you to
Do
make
what?
one of
Angles,
those.
distances.
2.5 hours.
What you
What
get
about
from-
Ray,
from the-
if you went to Ray's?
Yeah.
So it doesn't really give
wouldn't-
distance, it gives
It
angle.
wouldn't be that thick.
There is something in this
So he
angle.
can make a
There is
box.
obstructions in there.
There's a guy at Ray, he has.
So it's showing like when it comes around this
You have
corner.
like A values or
Yeah,
an array of values
Yeah.
or not, or
it's numbered. It's like 0 to 255 or something like that.
each one.
Yeah.
Maybe this is the
So they're
distance.
off of Carmody Boulevard.
It's not supposed. He says it's not distance. He says it's something
What's Ray's
else.
last name?
Effectivity or whatever.
Reflectivity. I think
what's
that's what he
Ray's
was
last
saying
name?
it was.
Leroy.
Yeah. What?
What's Ray's last name?
Scott.
Scott.
Ray Scott.
You say that too often.
He had, is it Rabbit Laser, and now he's got Rabbit Robot.
Rabbit Robot. Rabbit Laser is 1 and 2.
I know you already saw it. You want to see it? The website says
Technical schools and high schools.
these are the sensors, and these
So
are
these are robots.
no. The bottoms are the sensors, and the tops are
Shows
the
a lot more
emitters.
laser.
A lot more
Laser
laser, yeah.
Yeah.
That's big time.
So I had it backwards. So there's a lot more emitters.
You know, even in foreign countries. You know.
They
You
sell
have certain
international.
values?
I think it was giving me 8, but yeah,
Let's say you need,
we could
some
hook it up.
plastic cut out. Oh, God. Trying to think of some examples.
Is it a laser cutting application?
No, it's not printer, it's a physical laser. And a lot of times for
You have eight values
plastic
because
and
each
doesn't use
sensor
metal, but
has
sometimes you.
two values.
There he is.
Yeah.
Tell them what you
Eastern meter
do.
and Eastern meter.
We're trying to describe.
These are
the
new
laser
guys, and
Yeah.
we're trying to describe what you do, right?
Eastern meter.
Yell at
That's exactly what it's doing.
What do I do? The laser business.
Oh, laser business. I do lasers.
Laser sensor integrated.
Yeah,
So I sell laser machines that.
that's exactly what it's doing.
Go through the quality.
And it's got a little,
capabilities,
That's an
software, all
Atmega
that stuff, make sure they're
328P, so it's got a little Uno on
We
it.
distribute them throughout North America, the United States, Canada, Bahamas,
For sure, that's
Venezuela,
what that was.
Honduras. We treat Alaska like it's a different country.
From the day.
So,
Yeah, 328.
Up to what wattage?
we go from
That's
40
what they
watts
say.
now up to 80.
You're absolutely right.
We don't go below 40 in these really small machines because by the time you get that small, everybody wants to cut every corner possible to get the price down. But we don't want to cut all the corners. So we have a look. Our laser light source is from a glass CO2 structure. So once you go above,
See that board?
That
That board's bigger than a standard
no,
Uno.
it is a sealed glass.
It's
You would
bigger?
think like a glass cylinder. Mirror on one end, laser tube on the other, lens on the other end.
This one
So
that
you excited.
was on it?
Yeah.
Flashes. The laser light bulb itself could be anywhere from $300 to $800. Not a big deal. A Synrad is going to
It
be
still fits.
thousands.
Let me see.
And thousands of dollars.
What's
just
usually
for the
different
light
is
source,
this,
the laser source.
this chip here.
This
is the older one. This is what was on it, right?
No, this one's yours.
Oh, my God,
So,
this is the old Uno. This is a newer one.
Our laser
New ones
machines
don't have,
anything as subtle
well,
as, engraving names.
I'll show you what the real
I can
difference
engrave
is, but you can
a
see
postcard, halfway through the card.
how much further it sticks out.
Through a 3/4 inch
The
piece
real
of plywood.
difference, the clone had the
Same
pin,
machine.
so I soldered,
Today we're making all
that's
kinds
why
of
I
crazy
used
stuff.
my, so I didn't have to solder to the
Right,
robot
Carlisle,
to get the
Ohio.
power.
This one.
So this board is, it's just
No,
different, it's
bring
just a
your
lot
dad over.
different.
But,
But I did,
I work in commercial CAD/CAM software development.
which I don't think it's a huge deal. But I did end up having been that out just a little bit because the board stuck that far,
we
much
don't go
further
above
out.
80 watts because longevity, integrity of the beam, and the light source. They just don't.
I'm gonna have to test it.
So,
I got 8 of those things.
they're good machines.
And I'm sure some of them broke the last time, we had the combat. Some of them weren't working right. I don't know which ones, but they crashed.
Now,
Just all over the place.
You live in Middletown?
I have a Middletown address
I'm
because.
gonna get some of the
Monroe.
next
Yeah,
line
it's
up.
Monroe, just south of Middletown.
They cost $149.
I pay Monroe taxes.
Yeah.
Actually, I pay Monroe and I pay Middletown taxes. So,
I have friends that live in.
I wanna-
Monroe, and they have a Middletown postcode. So,
Oh.
Middletown post office.
We're
I
back,
grew up in Middletown.
we're back to that, are we?
Lived on 10th Street, near the old hospital.
That's cool.
Oh,
Nice driving.
short term. Oh, different path. What went wrong?
Well, I've decided that the other path was more open, I guess.
what's he using for collision avoidance? IR light?
Infrared, yeah.
Okay.
You see when it thinks it's really open, it takes off.
I've been trying to call you.
Guess I'm just gonna have to uninstall that app.
As far as I'm
What
concerned, it's not my problem. It's not my fault.
It probably isn't.
Wait, what up?
I've got an app
Republic
that
Wireless
it keeps blocking them.
Is it just me?
Well, you're the only one that I know of that tells me that it blocks.
I
that
can't
you
call Jim
me.
either. I mean, Jim, you just don't like me when I answer. So
Jim, you're the only person that tells me they can't call me. So
I got a new shipment of laser machines in. That's not the important part. The important part is all the robot parts, boxes that came with it.
ooh,
So there's 50 something boxes worth of robot parts.
cool.
You order them and they just throw that stuff in.
Okay, they'll throw it in. No, they'll just throw it in. Every night.
It'd be nice if it was just thrown in, right?
Because
The way you said it, it was like, oh, they added that on.
Yeah, right. Because I buy so much laser stuff, they are they're much more likely to be nice to me and say, "Oh, Ray, what's your hobby? How can we help you with your hobby?"
They know a good thing.
Yeah.
They want to keep the
Like, oh,
relationship
you want us to
solid.
help you find some low-cost robot parts? Yeah, no problem. So I have boxes of robot wheels and gearboxes, and my dad was picking up the boxes of nuts and bolts and screws. He said, "Yeah, this is just lead."
Yeah, right.
There's like,
Scrap metal.
you know, when I bought like M4 nuts, and I bought 30,000, and I bought, you know, an M4 by 12 Phillips head screws, 18,000 of those, and then, you know, an M4 by 12, M4 by 18, M4 by 16, M4 by 24, and I buy 18 to 20,000 of each size. And
You spill those,
Your
that
battery's
son
probably
of a
gone.
wood.
yeah, that would
Yeah, I'm sure it's getting weak.
Separate those if they make.
yeah. No, throw them away. I'm just buying more.
So
Yeah, that would.
So you build robots for like institutions and.
I've been working with
Ray needs to go to an institution.
I need to be in it. Get committed to one. I've been working with Ashland University
Up north.
and working with a couple of their professors and students on developing different robot kits. And their students are giving feedback as far as, you know, this problem or that problem. I've got a robotics club up in Dayton that they're doing evaluations and stuff. And we are improving programs. Literally at the shop, and we're writing new programs. I've been writing programs. I've been writing diagnostics programs. I've got one diagnostics program that I connect the USB cable to the robot and just tell it, you know, test bot mode 1, and it goes beep and goes into that mode. Test bot mode 2, beep beep, and it goes into, you know, taking test switches and stuff. So it's been a lot of fun. I'm getting to do some collision avoidance, and, you know, bang into the wall, come back, turn, go away to the other direction. Just as test programs. I'm working on infrared, Bluetooth, and Wi-Fi apps. Having fun with that. The biggest thing that's holding me back right now is wiring instructions and schematics. If I had step-by-step instructions on how to wire and assemble this robot, then I could go full bore. And we have enough parts to build about 800 robots. And we have, how many robot designs do we have? About 11 or 12. And we've got 8 more whiteboard to make.
I think it's funny you can't even keep up with your own designs.
There was I was pulled out one robot. I was like, what is the name of this? I can't remember the name of this robot. It was so bad.
Robot 1X.
Vapor lock.
Let's show, this is the guy who actually did this thing. And his actually works a little better, but he's got a lot of
A
room.
lot of space.
Yeah.
Oh, yeah.
There just aren't any good ways to measure angles. Knowing the angle between your robot and nearby objects and open pathways
Oh, yeah,
is super
that's
useful.
Yeah,
Challenges
here
like
he's actually using it to actually pick up an object.
mini sumo and others would be so much easier if you just know the angle. But for now, the options were limited.
Parkinson robot.
Depending on the sensor used, you're often left with gaps in the field of view and your sensor's slow response time. Robot needs to get around objects. Protractor is here to help. The protractor is an active infrared sensor that connects to your microcontroller. The protractor can sense angles to multiple objects in multiple pathways at once. With a 180-degree field of view, it can sense objects 20 to 30 centimeters away.
See, it's saying angles. That another demo program he had says like a whole array of numbers, and I don't have any idea what all those numbers actually mean.
Your project up and running fast.
He's got it avoiding all kinds of junk.
It's a lot of space though.
Yeah.
And
But
you're,
it's much more space in the box.
you said 20 to 30 centimeters away?
Which
that
is
like a
about 12 inches.
Is that like a cork floor?
20 is 8 to 12 inches.
I'm the creator of the protractor.
Is that a cork floor?
It looked,
It's probably Berber.
it didn't look like the kind of floor that I've got.
Those things don't run that good on carbon.
Because Berber,
Berber's a very short-haired.
I lived in a house where the guy was a paraplegic and he had a wheelchair before me, and it's real firm but cushy, so a wheelchair.
Yeah.
You can, this wouldn't be able to go on Berber, a lot of carpets, this would not. Wow.
It works okay on a little short carpet that I've got at the house, but
That carpet will.
that carpet is very, very dark and it has problems.
The reason I've been trying to call you is I wanted you to help me design a not such a complicated robot. We need a level 1. Instead of, my robots are a little bit more level 3, level 4 out of 5.
You need to go back to the original design of the Bitty Bot.
Need it simpler, easier.
All right.
And I got a few ideas. I wanted somebody intelligent, somewhat intelligent. Bounce ideas.
I'm in town again. Okay. Well,
As of like an hour ago, I just got sent out of town tomorrow.
A dash.
No, I some customer up in, they're like 3-hour drive. Go fix their laser and drive 3 hours. It probably would take like 25 minutes to fix their laser.
But you got 6 hours to drive.
Yeah. I have a sinus infection, some tickle in my throat, and appendicitis.
You got a
Nice.
appendicitis.
So my doctor said,
Ray may be out of it for a while.
any infection in the appendix is appendicitis. So I haven't.
It's not gonna. I have surgery tomorrow or something. Your white count's not going through the roof, has it?
He says as of like 2 or 3 years ago, the more mild infections they treat with medications.
The Z-Pack or.
No, this is 2 medications that they say they're going to, in case it's viral or bacterial.